Hello and welcome to STAT 441 at Virginia Commonwealth University. This is the first video lecture for Chapter 1 from the text that we will be following. Please make sure you have a copy of the text while you're working for this course. Let's start with some basic definitions and terms that will be used throughout this course, starting with what is statistics. So statistics can be called a science of data, and it involves collecting, classifying, summarizing, organizing, analyzing, and the interpretation of data. There are two common types of problems that we will come across. The first one is where we need to summarize, describe, and explore the data. And the second type of problems would be where we need to draw an inference about the nature of the data set. And for doing this, we use a sample data set. Statistics can be divided into two branches. The first branch is the descriptive statistics branch, which deals with the first type of problems, the organization, summarization, and description of data. And the second branch is the inferential statistics branch, which where we make inferences about the large data set using a sample of data. Here are a few fundamental elements of statistics. The first term is population. Population is usually the large data set that is our target of interest. The subset that we collect from the target population is called a sample. When we make a measurement on the object or the subject, that object or person or thing is called the experimental unit, and the characteristic or property of the individual experimental unit is called a variable. The fifth element of statistics is the measure of reliability, which basically gives us a numerical measure of how good the inference is. So this measure of reliability separates the science of statistics from the art of fortune telling. Here is an example. And engineers at University of Kentucky Transportation Research Program have collected data on accidents occurring at intersections in Lexington, Kentucky. One of the goals of the study was to estimate the rate at which left turn accidents occur at intersections without left turn only lanes. This estimate will be used to develop numerical warrants for the installation of left turn lanes at all major Lexington intersections. The engineers collected data at each of the 50 intersections without left turn only lanes over a 1-year period. At each intersection, they monitored traffic and recorded the total number of cars turning left that were involved in an accident. So in this problem, let's identify the variable and the experimental unit first. So data was collected on 15 intersections. So the experimental unit is an intersection without a left turn only lane. And what are we measuring here? We are measuring the total number of cars turning left that were involved in an accident. So this is our variable of interest. The target population here is all major intersections in the city, and the sample will be the subset, which is the 50 intersections that were monitored by the engineers. The inference that we are trying to make is using the sample data, and we will make this inference about all major Lexington intersections. Okay, so this with these basic elements, we can put together what descriptive statistics problems look like and what inferential statistics problems look like. So for descriptive statistics problems, these are the 4 elements. We identify the population and sample of interest. Then we identify one or more variables that we are trying to investigate. We use tables and graphs and some numerical summary tools to put the information together and then use this to identify patterns in the data. For inferential statistics problems, The first step is to identify the population of interest, one or more variables that we are interested in. Then we pick a sample of the experimental units. Using information from the sample, we draw an inference about the population. And then the last element will be the measure of reliability for this inference. Let's look at the types of data that we will come across. There will be two main types of data, quantitative and qualitative data. Quantitative data are those that represent the quantity or amount of something, and it can be measured on a numerical scale. For example, the power frequency of a semiconductor. It can be measured in megahertz, and it's a numerical quantity. Another example is breaking strength of steel pipe. Again, this is a numerical measure, and the unit here is pounds per square inch. So anything which has a numerical value is quantitative data. The second type of data is qualitative data, also called categorical data. It does not have a numeric interpretation or a quantitative interpretation. They can only be classified. So it's basically like classification groups. Here's an example, a set of n occupations corresponding to a group of n engineering graduates. This will be a qualitative data because it's just the type of occupation, it's a category. Another example, the type of pigment used in an anti-corrosion epoxy coating. Again, there are two types of pigment here, zinc or mica. Doesn't have a numerical interpretation. So this is a qualitative or a categorical variable. Let's look at an example and identify each of the variables here as quantitative or qualitative data. The data here is collected for all highway bridges in the United States. And then out of the 100 variables measured, these are some of the variables that are listed here. The first one is length of maximum span in feet. This is quantitative because it's a numeric value. Number of vehicle lanes, again, it's numeric, so it's quantitative data. Toll bridge or not, qualitative because it doesn't have a numeric value. Average daily traffic, quantitative. Condition of deck, there are three categories here, good, fair, or poor, so it's qualitative. Bypass or detour length in miles, quantitative. Route type, interstate, US, state, country, or city. Again, this is a qualitative variable. Okay, the next step is to understand how we can collect data. And we collect data by gathering a sample. And there are various ways in which we can obtain a sample. The first one would be to collect data from a already published source. So you can just use the internet or some published source. The second would be when we collect data from a designed experiment. And then the third one would be collecting data from an observational study, such as a survey. And let's see what each of these design, experiment, and observation study means in a very basic definition. So for a design experiment, it is the data which is collected when a researcher has full control over the characteristics of the experimental units that are being sampled. That means the researcher can make changes in the experimental units. It can apply some kind of treatment. And we usually have multiple groups that are of these experimental units. These groups are called treatment groups. And there is a control group, which is more like a group on which no treatment is applied or just a placebo is applied. On the other hand, observational studies are another data collection method in which the experimental units are observed in the natural setting. That means the researcher has no control and cannot make any changes on the experimental units. For any type of sample collection, this is what we are looking for. We want a representative sample. That means the characteristics of the sample should mimic the characteristics of the population of interest, and that gives us the best results. A very common sampling technique is called a simple random sample. What that means is that each experimental unit in the population has an equal chance of being selected in the sample. So that gives us a representative sample. Okay, let's summarize it. Why do we need statistics, and what is the need for statistics, especially for engineers and scientists? Because this enables them to make inferences, make estimates and decisions about the population with a known measure of reliability. So there is no guesswork here. What we are doing is making intelligent decisions and inferences using what we observe from the data, and then critically think about the results that we are making. Thank you so much. Look for the next lecture for chapter 2.